Hi, everyone. Welcome to this talk, hybrid caching in .NET. So my name is Jody Donetti. I'm a principal engineer. I've been doing coding, R&D, stuff like that for about 30 years, so a bit of time. In my career, I worked with a lot of different types of caches: memory, distributed, hybrid, multi-level, HTTP caching, offline caching, and CDNs. And I even worked at a CDN company. Some years ago, I created FusionCache, which is a free .NET open source project, a .NET hybrid caching library. And for my work on FusionCache, I received both a Google Open Source Award and a Microsoft MVP Award, for which I'm pretty thankful. So, what now? How will this talk go? I had two options here. I can either show you one or two things, but deeply, really well, but then you will miss a lot of stuff that I think will be cool to see and useful in your day-to-day job or your open source project or whatever. Or, on the other hand, I can show you a lot of stuff, less deeply, but it will give you like a bouquet of things to pick from, and if you're interested, you can then deepen the subject online later, maybe on the FusionCache documentation or somewhere else. And I decided to pick the second one. So because of that, I will go a bit fast, but my hope is that I can show you a lot of interesting things that really you can use from tomorrow, well, not tomorrow because it's NDC, but from Monday, in your real-world projects, if the screen is nice enough to keep up. OK. So you'll discover something new. And again, you can deepen the subject later online, but here I'd like to show you a lot of stuff that you can pick from. So without further ado, hybrid what? So what is this hybrid caching thing? So basically, there are three main types of caches: memory caches, distributed caches, and hybrid or multi-level caches. Now, memory caches they store data in memory, but not just in memory as in implementation detail, in the same memory space as the application using them. This means that they are basically a kind of glorified dictionaries. They are dictionaries plus some form of eviction, okay? And as you can see from the illustration, the application talks directly with the memory cache, and that is local, and remotely with usually a database or remote service, whatever. And this is how we can use them. So this is a memory cache, the one inside that you can find out of the box in .NET. And you can call cache.getterCreate. You can specify the type to have strongly typed results. You have a cache key, usually with a dynamic part, in this case the ID. And then we have the so-called factory, which is the way we ask the cache, hey, if there's a cache miss, so if the value I'm asking for is not in the database, do this to grab the value and then save it in the cache. And finally, usually some options. Now, these are some examples of memory caches in .NET. Do not confuse memory caches, the type in general, with memory cache, which is just one type, the one out of the box in .NET. We have bitfaster.caching, fast cache, fast-cache, which is a different one, lazy cache, which probably is the one mostly known by the .NET community, and of course, Microsoft memory cache, the one out of the box. Then we have distributed caches, which are a different thing, because they are basically, they represent a remote key value store. And you can think of them as like Redis cache. Now, the way to think about them is like a database, in a way, because they are remote data stores where you store and read data. And usually they are less feature-rich, but because of that, they are super fast, way faster than a normal database. And in .NET, they are represented by the iDistributed interface, the generic iDistributed interface, plus the available implementations. And as you can see by the illustration, the application talks with that remotely, and it needs to handle both serialization and deserialization. This is how you work with the distributed cache in .NET. And as you can see, the code is already a bit longer than before. Why? Because, as I said, we need to take care of serialization, deserialization. So here we are getting the binary payload, the byte array, basically, from the cache. If it's not null, it means that we had a cache hit, so we found the entry in the cache. And in that case, we just deserialize that into a product, in this case, or whatever is your object model. Otherwise, we need to go call the database, which can take some time. And then we need to then serialize the product that we receive from the database, EF core, Dapper, whatever that is, it's the same. We serialize that to a binary payload, and then we set it into the cache. And this is already problematic, and we'll see why in a moment. But this is what a distributed cache is. Examples of distributed caches, which again in .NET means implementing the shared iDistributed cache first-party interface, are one for Memcache, MongoDB, SQLite, Amazon, DynamoDB. There are many. And if you go, by the way, on the FusionCache repo, there's a rich documentation, and I listed the main ones that I think can be useful in your day-to-day job. And finally, probably the most used one, which is Stack Exchange Redis, which is made by Microsoft. It's an implementation of distributed cache made by Microsoft based on the Stack Exchange.Redis open source library. And finally, we have hybrid caches. Hybrid caches are the most advanced caches. They combine the best of both worlds, basically a memory level called L1 and a distributed level called L2. As you can see from the illustration, the application talks only with the hybrid cache, and it's the hybrid cache that then maybe can talk with the distributed cache or the memory cache, L1 and L2, if needed. And as you can see, it's the hybrid cache that is taking care of deserializing and serializing. So this is already something that we offload to the hybrid cache. Now, we can use them like this. This is very similar to the code we saw at the beginning for the memory cache, a sign that they are way easier to use than a distributed cache. And so here we can see cache.getRset, the type, cache key, the factory, and the option, the bare minimum. So we do not have to do a lot of stuff on top of that. Examples of hybrid caches, sorry, the title, I did the slide last minute, but examples of hybrid caches and multi-level caches are FusionCache, which is hybrid and which I created, Cache Tower, Cache Manager, and Easy Caching, which are instead multi-level. We see the difference in a second. And finally, the so-called new kid on the block, Microsoft HybridCache, which is, of course, hybrid. What we will take a deeper look at in this course are FusionCache and HybridCache, and not just because one is by Microsoft and the other I created. You'll see why, by the end of this lesson, I think this session, you will see why that makes more sense. So the question now may be, okay, cool, but why? Why should I use HybridCache? What is the value? So first thing, memory caches are easy to use, very easy to use. They have super great data locality, meaning the data in the cache is very near to the application using it, because again, it's a dictionary, so it's very near, it's a memory access away. And because of that, it also has basically almost no cost, just a memory access, meaning it does not need to go on the network or do serialization and stuff like that. And the availability is 100%, meaning it's a dictionary, it's always there, which can look strange to say, but you'll see in a second why that is not the case. On the other hand, we have a problem with cold starts and horizontal scaling, meaning at every application restart, the cache is wiped out because it's a dictionary. Of course, you restart the application, everything is empty, meaning it will need to be repopulated from the database again, so more queries to the database. And for horizontal scaling, it means that if we need to scale out horizontally with multiple nodes, or if we have even just multiple applications using the same data, data is not shared between multiple nodes or multiple applications. So we have a problem there. On the other hand, distributed caches are basically the specular image, because they are less easy to use. As we saw, you have to code the deserialization part, yada yada. Data locality is not so great because they are remote by definition. And out of process, typically remote, there's a cost associated. Every time we access a distributed cache, we are doing a network call and we are deserializing data every single time, so CPU and memory. And the availability, because yes, usually you spin up a Redis instance or whatever and it's there, but that may not be the case all the times. It may go away, it may have a problem reaching the instance. On the other hand, cold starts and horizontal scaling are great because when you restart the application, since the Redis instance, for example, or memcache is out of process remote, it's not wiped out. So the data is still there, and you don't need to repopulate it again from scratch. On the other hand, at the same time, horizontal scaling is great because multiple nodes or multiple application instances can access the same distributed cache. And so there's a sharing of data, meaning we will do less queries to the database. And then hybrid caches. Basically, they have all the pros of L1, the memory level. They have all the pros of the memory caches and all the pros of the distributed caches because they mix the L1, which is the memory level, and L2, which is the distributed level. Basically, they are easy to use, as we saw already. The data locality and cost and availability comes from the L1, the memory level, whereas the cold starts and horizontal scaling capabilities come from the L2, the distributed level. So it gets the best of both worlds. And yes, of course, when the hybrid cache will talk with L2, the distributed level, we will have a network cost and deserialization, but only once for the first cache miss, because as soon as the data is found in L2, it will be copied down to L1, all automatically. So one thing to point out is that hybrid doesn't mean necessarily L1 plus L2. Meaning, by using a hybrid cache, you're not forced to enable a second level. It's optional. The L1, the memory one, is always there because underneath is just a dictionary. L2, you can use it or not. You can use hybrid cache only with L1, as in this image. And of course, the first question may be, cool, why? I mean, I'm just using a memory cache underneath. Why don't I use directly the memory cache? That's a good question, of course. So 2 main reasons. The first is that you get basically a superpowered memory cache because usually what happens, and here it depends on the library that you pick, you will have stampede protection, which is not always present in normal memory caches because they are lower level. Instead, hybrid caches are higher level. You have more features in general, like your refresh, factory timeouts, or fail-safe. These are specific to FusionCache, we'll see in a moment, and are very useful, but other libraries can have other features. And they usually have observability built in, so logs, traces, and metrics, so OpenTelemetry, for example. But most importantly, the second one is that we can transparently go multi-level with no changes in our code. It's really hot here. With no changes in our code. What does it mean? Well, it means that it doesn't matter if we want only L1 enabled, or if we want L1 plus L2, so a memory level and a distributed level, because either way, we will be working with a transparent, unified API. So this is really powerful because we don't have to switch between a memory cache and a distributed cache. We can just change the initial configuration during setup, and we're good. For example, this is the code to work with a hybrid cache. In this case, it's FusionCache, only with only L1 configured, so only the memory level. And keep your eyes on the code. This one is the same code for L1 plus L2. In this case, this is Redis as the distributed cache, and the serialization format is protobuf. And this one, instead, again, same code, is for L1 plus L2, but where the distributed cache is memcached and the serialization format is JSON. The code is always the same. So this is really powerful, again, and it can be used only, it can be enabled L2 with one line during setup. So you don't need to go and change all the calling code that you created in your application. Another example that is usually used with hybrid cache is that locally when you work, or when you develop your application, you only enable L1 because who cares about the distributed cache? I'm just in my local development environment. But when you then deploy in staging or production, you then enable only there the L2, the distributed cache, because it's production. So of course you want to scale out, etc. And what you can do this, the way to do this is just during setup, and if m.is development, and then you do only L1. Otherwise, else you enable the L2. And so, as you can have guessed, I kind of like hybrid caches. So one final note: a hybrid cache versus hybrid cache. Hybrid cache altogether is the type in .NET which came out in .NET 9, the one by Microsoft. A hybrid cache is like saying a memory cache is just a generic type. I'm saying this because, for example, FusionCache, which is my project, came out in 2020 and is a hybrid cache. It doesn't have anything to do with hybrid cache from Microsoft, which came out in 2025. Okay, so one final note here, because I think it may clear some confusion: hybrid versus multi-level. I frequently said in this couple minutes, hybrid / multi-level, as if they are the same thing. They are very similar, but they are not. And the way I found to differentiate them with you is that since we're all developers, I'm using code. So a multi-level cache supports any number of levels. So if we want to express this as code, this is pseudocode, this is not real, it will be a class multi-level cache with one property, levels, of type list of a generic iCache level. This is basically the mental model, okay? Whereas a hybrid cache is something like this. We have L1 of type iMemory cache in this case, and L2 a distributed cache, question mark, because it's nullable. It may be there, maybe not. It's optional. So the first note that you may have is, okay, cool, so hybrid caches are less than multi-level caches. They do less because one is just 2 levels, whereas multi-level caches are potentially infinite. Technically, yes, but in reality, at least in my perspective, they are more powerful hybrid caches. But why? First, the limitation is really pragmatic with, honestly, no real-world impacts, meaning in 20+ years, I never had the need to go more than 2 levels. You need the memory for some things and the distributed for others. You don't need 3, 4, 5 levels, so it's not really a limitation per se. But this seemingly limitation, that ensures stronger foundations to build upon new features, new richer features. And that allows richer design with more advanced features, some of which we'll see later. And also, they allow more granular control over the operations that you do. For example, in a hybrid cache, since we have L1 and maybe L2, it's clear, it's defined, we can skip L1 or L2 per call, per single operation. We can do remove and skip L2, L1, whatever we need. In general, in the end of the day, they just work, meaning they usually are easier to use overall, even in complex scenarios. And in my opinion, they are basically the right balance between a potentially infinite list of levels, which really doesn't make a lot of sense, and a richer set of features. So let's talk about the first one, FusionCache. I work with, as I said, with a lot of types of caches, and basically that gave me a bit of experience with all different types of caching environments, even HTTP, offline, etc. And so I learned I had to deal with a lot of issues, real-world issues in production, and I need to know how to prevent them when possible, or how to mitigate and solve them when they were inevitable. On the other hand, the open source community always gave me a lot. And when I say me, let's be honest, I mean all of us. I mean, we live in open source. And I give back sometimes, but nothing major really, small patches or fixes and stuff like that. So I decided in 2020 to give back more, and I created FusionCache. I tried basically to condense all these caching experiences into one unified, cohesive package, and that was easy to use. All of that to solve real-world problems that I had to face and had to solve manually the first time, and then I packaged them up in this library. So it's a hybrid cache. For L1, the memory level, it uses iMemory cache, and for L2, it uses iDistributed cache. This means that any existing iDistributed cache implementation out there, and there are many, already work out of the box with FusionCache as L2. It transparently handles 1 or 2 levels, as we saw, and 1 or more instances or nodes, without changing, again, a single line of code. Here's how to register it via DI. Services.add-FusionCache, and basically that's it. And yes, you can also do new, and that's not a given, as we will see. Or you can configure a lot more. You can customize certain options, distributed cache, serializer, backplane. There's a Fluent builder that can be enriched. And here's how to use it. For example, this is MVC, but it's the same thing with minimal APIs or a console application. We have the iFusionCache parameter in the constructor. We just save it, and then we call it in the action, in this case, the get action. And as you can see, small note, you can see these, I use a different syntax for the options. I use the options, Fedora options.setDuration. This is interesting because it's using the default entry options, which is a way to say, this is the default set of options that I want in this cache, in my cache. And then when you do this call, FusionCache will duplicate them and then allow you to specify, to let's say, customize it for this specific method call. It's really useful and as an inheritance mechanism. It has a lot of features. I will not go over all of them, but just to give you an overview of what may be interesting, I split them into 4 categories: resiliency, performance and scalability, flexibility, and observability. I'll go very quick because I don't want to bother you. But resiliency, we have full cache stampede protection. We have a fail-safe mechanism. I made the bold ones, the ones that we will take a better look in this session, and auto recovery. We can go L1 or L1 plus L2. We have the support for the backplane, which is cool for multi-nodes, you'll see in a moment. We have eager refresh and factory timeouts, which are amazing for performance and for when things go south, and conditional refresh and background distributed operations. About flexibility, we have the ability to have multiple named caches, which is not a given, which should be, but usually it's not the case. Think of it like HTTP named caches, but for caching, HTTP named clients, sorry, but for caches. Support for key services, tagging, which is a monster feature. It's really, really complex. Well, it's very easy to use. Creating it has been very, very complex. So I go there. I go more in detail in the documentation if you care to take a look at that. Clear support, which is not as easy as it looks like. Adaptive caching, it supports dependency injection with the Fluent builder that we saw, and immutability. And finally, observability. We have full support for logging, traces, and metrics via OpenTelemetry and events. Now, Yeah, okay, final note, it targets .NET Star 2.0. This means that it can run everywhere. If you have something in .NET Classic, the 4.78, whatever, it runs there. Modern .NET, Unity, Mono, you name it, it runs everywhere. It is fully sync and async, meaning you can use it even if your code has a call side that is sync only, which is important in some cases. A unified serialization abstraction to work with any distributed cache, to work with byte arrays, basically, for the L2, and a rich set of options, both global and per entry. Docs. I really like docs. I will go fast here, but if you are interested in the subject, I put a lot of effort in the docs, and they're usually liked by the community. I go on every feature with the rationale, why I did something in a certain way, examples, diagrams, step by step, there's everything. And also, all the library is completely documented via IntelliSense. So when you are discovering it or a new feature, you will find all the documentation there. Who's using it? Because, of course, you can say, oh, yeah, your nice little project, but is somebody using it? Well, it's used by a lot of projects, both open source and private, and companies. And regarding companies, they go from very small ones to pretty big ones, like Have I Been Pwned, which, by the way, we have here the main developer that will have a talk tomorrow. Tomorrow, so I suggest taking a look at that talk. Downtrain, the online course by Nick that was in the previous session, and even Microsoft itself. So Microsoft is using FusionCache as the caching engine of their data API builder product. They have this product which is useful to create, let's say, no-code API, HTTP, GraphQL, stuff like that. And as the caching engine, they're using FusionCache, which is a bit of a testament. Final thing, licensing, since the .NET space sometimes sees some changes around, stuff like that. No, nada, nine, nope, I don't know how else to say it. Always been free, it's free, always will be free, so we'll not change it. I'm just giving back to the community a little part of what I already received along all my career. So I'm done. I don't even accept donations, so I'm cool. So let's look at concrete issues that you can find in production. Cache stampede. This is probably the most famous one. Imagine this scenario. You have a lot of requests that arrive to your service or API or website or whatever for the same data, which is not in the cache because it expired, and at the same time, even if it's just not expired, even if it's the first time you see this data. So multiple requests for the same data at the same time. Without any special care, all requests will do this. We'll read from the cache, we'll check the cache miss because it will see that it's not there. Then it will call the factory, meaning they will go to the database to grab the value. And finally, they will write the value to the cache. Pretty normal. But it means this. And here we can see visually that 4 requests for product 1 and 4 for product 2, they will end up basically generating 8 database queries. But product 1, in a certain moment, is always product 1. It doesn't need to go to the database for all of the requests, right? So imagine the scenario for 100 concurrent requests, or 1,000, or even more. I've been there. It's a waste. It's a real waste of resources and time. And it's something that in production, when you have a peak of traffic, can tear down your database because it's a lot of traffic that is honestly useless. So, of course, during peak traffic, that's a given because during Black Friday. And nice to meet you, Cache Stampede. So what can we do? Cache Stampede protection. Now, some library, but not all, so you should double check the library that you decide to use, have integrated cache stampede protection. Basically, these libraries, they coordinate the cache calls and the factory execution together for the same cache key at the same time, all automatically. And what should you do to be protected? Basically, instead of doing this, which I keep seeing again and again in production code, this is wrong, you should not do separate calls. You should not do get, the usual if null or something like that, which is doubly wrong, and then a set, because these will not allow the cache to coordinate the calls. It will not have an opportunity. For the cache, it will be 2 separate calls, get and set, and it cannot help you. Instead, what we do is this, cache.getOrSet. I say getOrSet, but it can be getOrCreate, getOrAdd. Naming is hard. Every library has different names, but you get the idea. If you do these and specify the key and the factory, meaning the lambda, the logic to go to the database, you will be protected. If the cache library supports it, double check it. Basically, we will turn these to this, which is way better because it will go to the database only once. But as you can see, it will go to the database only once per different cache key, so per product in this case. This is important because request queries to the database for product 1 should not block queries for product 2. And this is what cache stampede protection will give you. Now, it's a form of request coalescing, meaning the multiple logical requests are coalesced into one. And the thing is that sometimes, actually a lot of times, people think that if the library they are using have a method, as a method called get or set or similar, then they will be protected from stampede. And this is false. So much so that the most prominent example is memory cache. Memory cache does not protect you from cache stampede. So 1,000 requests, 1,000 database queries, no protection. On the other hand, FusionCache and HybridCache, the one by Microsoft, fully protect you from cache stampede. Keep this in mind when you are using something like, when you are caching something, check the library to see if it protects you from cache stampede. Okay, so we reduced the number of database calls, but still, sometimes things go south. So what happens when there's a database failure? Well, basically, it can happen for different reasons. It can be a query timeout, because maybe we made a bad query. It happens. We've been there all the time. We've all been there. Or maybe the query is good, but there's a missing index, so it will super slow and hit the timeout of the database. Or maybe there's a database restart, because maybe an engine update or a crash. Or maybe the database is good, the query good, we did our job well, there's the index, but we have a network connectivity issue. It's a distributed system, a distributed component, so things can go south. What happens then? Well, this happens, meaning a problem in the database, an error in the database is an error on the cache, which is an error on the service, and finally, our end users. And this is really, really bad. So basically, our service reflects the condition of the database. If the database throws an error, your service will throw an error. And again, this is really bad. But here's the problem. If the data in the cache is already expired, because we cache it for like 10 minutes, and now it's 10 minutes and 2 seconds. So the data in the cache is expired. And the database in this moment is not available, or unreachable, or down, or whatever. Is there really something we can do? Because we need to get the data from somewhere, and the data is gone, and the database is down. So, fail-safe. This is a FusionCache feature. And basically, it's a mechanism, a protection mechanism that basically allows you to say, look, if you cache something for 10 minutes, and now it's 10 minutes and 1 second, and the database is down, is it really that bad to use for a bit more the data that you just expired, that just went away, hypothetically? No, most of the times not. Instead of throwing an error, it's better to just use what was good, what has been good for 10 minutes. Who cares for a couple of extra seconds? It's like a second chance, if you will, for when poop hit the fan. I like to say it like that. So basically, it turns this into this, because it protects us, and the end result is that our users will not know about anything. Now, let's say we have a duration of 5 seconds. Normally, without failsafe in a normal cache, what happens is that after 5 seconds, the entry, the value in the cache, is expired, and therefore evicted from the cache. It's not there anymore. With failsafe, after 5 seconds, the entry is considered expired, and so it will trigger a refresh, as it should, but it's still there in case bad things happen. So it's not evicted. With failsafe, basically, the duration, the 5 seconds in this case, becomes a virtual one or a logical one. And again, in both cases, after 5 seconds, there will be a refresh. So from a behavior perspective, nothing changes. It will change only when there is a problem on the database. In case of problem, the entry is temporarily resaved into the cache. It's not just returned, the old one, it's also resaved for a smaller amount of time. And you can control that with 2 different options, 2 different parameters. It's resaved, by the way, instead of just returned, because otherwise, if the database is down and the entry is logically expired, all the requests coming in will see the cache miss, will try to go to the database, and will bombard the database in a moment where it is down or unreachable or is having issues. So it's the worst possible moment to keep asking, hey, give me the data, hey, give me the data. It's not like that, it doesn't work like that. So we give it a little bit of time to get back on its knees. And here's how to use it. Simply, when we do the call, when we specify the options, we can just say .set failsafe. There is a set of fluent methods that we can use. And in this case, we just enable failsafe, and we specify 2 different time spans, meaning for how long we want to recache something when there's a problem, and the other one, the first one, is for how long should this dance of retrying and retrying and retrying go on at the most. Because maybe we don't want to go on forever like that. Maybe after a day or an hour, depending on their use case, it's better to say, look, you know what? It's too old. The data is too old. I just prefer to say to the user, we're having some issues. I'm sorry. Basically, without failsafe, your service, as I said, reflects the problem in the database. And with failsafe, reds are gone, meaning the downs of the database or the unavailability, unreachability disappears because we are protected. The cache will protect us from that. Minor notice, the name is also an homage to a movie by Sidney Lumet. I will suggest you to see it. It's really beautiful. Now, cool, but the database is not just up or down, meaning the world is not just black and white. There are shades of gray, meaning the database may be totally fine and reachable, but maybe it's overloaded. So what happens? This happens. Maybe we have a high workload temporarily on the database. Maybe we wrote some bad query, as we saw before, but not enough to trigger an error, just slow. Maybe there's a missing index or network issues, somewhat like before. Basically, when the database is low, your service is low. And this is not so great. So, again, but the data is expired, and the database is low. What can we do? Well, maybe we can act proactively. Eager refresh. Eager refresh is another FusionCache feature that I think you will find useful because it allows us to basically preemptively start the refresh for something that is about to expire. We can simply specify a percentage of the duration, so it's relative to what we are working with. If we cache something for 10 minutes or 10 seconds or 10 hours, it will be a percentage of that. It is expressed as a floating point from 0 to 1, as is pretty common in computer science, and it's a percentage of that duration. Now, the first request that will reach the cache for something after that threshold will basically trigger a background refresh automatically in a non-blocking way. This is important. So the data is still valid, so it will be returned immediately, but also it will trigger a background refresh at the same time in a non-blocking way. Basically, to enable it, we can just do set eager refresh 0.9, which means in this case 90%, and we're done. This means that if something is requested, so if there is a need for a certain piece of data, it will be automatically refreshed a bit earlier so that you will not encounter the slowdowns of a refresh to the database. But eager refresh can help us only in that small window. It's called the eager refresh window, meaning only after the whatever percent we decided and before it expires. Basically, what happens if there are no requests in that window, but only after the data is already expired? And so in that case, we will need to wait because the factory is blocking. Or maybe the request, in this case, request number 3, came at exactly the right time, but it is painfully slow. It may happen. The database is super overloaded. It's not like 1 or 2 seconds, maybe 4 seconds, like in this case. So we will cross over the expiration mark. And in this case, at a certain point, after R4, basically, we will need to wait, because we will need to wait for the background operation, the background factory, to complete. So there's no way around it. All of this because the fundamental issue is that the factory execution is a blocking operation. We need to wait. We need the data. We ask for the data, and we need to wait. So, but the thing is, if the data in the cache is expired, the factory execution is a blocking operation, and the database is low, is there really something we can do? And by now, you probably already know where I'm going. Factory timeouts. So, the idea is that we can specify, look, when you need to do a refresh, do your thing, but I don't want to wait more than X amount of seconds, milliseconds, whatever that is. And in that case, that is a special timeout, basically. And if that timeout is hit, what happens is that FusionCache will use the stale data, because it was valid before, but at the same time, we'll move the factory execution in the background and we'll let it complete there without blocking. So we will give it a chance for fast operations, which are pretty common, I hope, in your scenario. But when poop happens and something becomes slow, we wait, but not more than X. After X, we just use the old value and we'll let it finish in the background. This is really powerful. Basically, we can go from these, which is a get or set call, check cache, and then factory execution that is blocking, to this, where basically it will block for some time, but after the timeout that we expressed, it will save the old value temporarily, will let the factory complete in the background, And when finished, it will automatically update the cache, and the value will be available for everyone else to use. So again, it's like the best of both worlds. We are decoupling when the method call is done from when the new value is available. To use it, something like before, dot set factory timeouts, and we can specify 2 timeouts. These are 2, by the way, because we can specify 1 timeout for when we have a value to fall back to, which is usually the ideal situation if there is a problem with the database. But also, we can specify a different timeout, which is usually longer, for when we do not have a value to use as a fallback. And in that case, basically, it's a sort of a fail fast. Like, look, if there would be a problem, after 1 second, I'm good. In this case, it's 1 second. So if there's a fallback value, after 100 milliseconds, it will use that. Otherwise, at most, after 1 second, it will stop anyway and will throw an error or use another default that you can pass. Basically, in the end, by combining the 2 features that we just saw, eager refresh and factory timeouts, we will go from this to this, which is really beautiful. And this is hand-drawn because that's one of my fetish. I like to draw illustrations. But really, this is really, really similar to a production environment that I observed with millions of users per day. We did not have any problem. Everything was reasonably fast. We discovered some peaks in the tech SEO, so Core Web Vitals, if you know what that is. And we were like, damn, sometimes it's really slow here and there. Probably it's a cache miss. So I finishing developing this feature. I deployed to production, and basically it became like this. Again, this is drawing, but it was like this. Now, a couple more issues. I like to show issues because this is something that, whether you like it or not, you will encounter in your career. If probably you already encountered some of these. But I also always show solutions. So that's why it's nice to see this. So cold starts. If you're using a normal memory cache, or even a hybrid cache, but only with L1, the memory level, that is basically a dictionary, as we saw. So what happens during restarts? Well, if the application restarts, the cache becomes empty. It's a dictionary. And so this happens. The app restarts, and the cache is now empty, meaning the cache now needs to be repopulated again from the database, meaning more queries to the database. Multiply this for a lot of nodes, and it's a problem. And about multiple nodes, horizontal scalability, meaning what happens when we have multiple nodes or multiple pods or multiple instances of Azure App Service or whatever floats your boat, or multiple applications, maybe a back office and a front office, or different services in a microservice architecture, and blah, blah, blah. Well, if you are using only a memory cache or an hybrid cache with only L1, each memory cache is its own isolated world. And it means that it needs to be repopulated from the database. So again, more and more queries. This happens. Each node, to do the same thing, will need to go to the database because each instance has its own memory cache, its own memory dictionary. So, distributed cache. This is the first thought that people have. Not so fast, no pun intended. We can share cache data between nodes and apps thanks to a distributed cache. This is true. But if you're working directly with a normal memory cache, what happens is that we need to go and change in our code all the places where we wrote these, and now we have to change it with these. This is to get back to the fact that even a memory-only hybrid, a hybrid with only a memory level is better than a normal memory cache, because instead of doing these, that incurs, by the way, an extra network cost and serialization cost for every single call. Instead of doing these, we do this, L1 plus L2, if you're using a hybrid cache. Basically, with a hybrid cache, we just enable L2 during setup. And how to do that? In this case, the FusionCache, we'll see in a moment, hybrid cache. Dot with serializer, we specify the serialization format. There are a lot of different adapters for the most common serialization formats. It's protobuf, memory pack, message pack, JSON, you name it. There are all of them. And then we do dot with distributed cache. We do one change during setup, and we're done. L2 is now enabled, and it's automatically, the hybrid cache, in this case FusionCache, will automatically manage the dance between the two levels. And again, any distributed cache implementation will work out of the box. So, as I said, all the dance will be automatically handled. And for example, a cache miss on L1, the memory level, is then followed by a cache check on L2. And if there's a cache hit there, the value is not just returned, it will be copied automatically to L1 so that all the next requests will be super fast, basically a memory access away. But also, when you do a cache.set or a move, when you basically update the state of the cache as a whole, the changes are automatically propagated from L1 to L2. So you are on a node, let's say you have 10 nodes, you do one update there, and we'll go to L1 and to L2. So all the other nodes will be able to see the change. Basically, we can just keep using a cache, and that's it. But there's an issue here. And the issue is that with an L1 plus L2 setup, what happens when there's an update to a cache entry? We just saw it. Oh, you will write L1, the memory level, but also L2. Cool. And what if the value that we just changed was already present in an L1, but on other nodes? Basically, we have a problem of we will need to wait for the expiration of the other nodes, which means that we have like 10 nodes, all with product 1, for example. We do an update on a certain node. The HybridCache will update that node that received the update command and the distributed cache. But that product 1 in the old version will be still present on all the other nodes. And this is cache coherence problem. The cache becomes, as a whole, incoherent. And this is bad. What can we do? We can use a backplane. A backplane is a very lightweight message bus that a HybridCache, like FusionCache in this case, can use to propagate messages between all the nodes. Basically, if I'm one node that I'm receiving the update, and you are all the other nodes or pods or whatever, it's a way for me to say, guys, I updated the distributed cache, do your thing. And then you go and maybe update your local version of the cache. Maybe you will just invalidate it. It's already done. It's already built in. You don't have to do anything. But the cool thing is that with just this line, it will work. I just have, last week, somebody in the community contacted me saying, oh, I use FusionCache, it's cool. Oh, can you tell me more about your environment? I said, yeah, we are using we are in a microservice environment with more than 20 different services, and we have more than 200 pods instances. And basically, we were facing the issues of like, guys, we need to speed things up, we need to use the cache, but then, you know, memory is fast, but then we have problems of multiple nodes, how can they do? Basically, they told me that they just used the FusionCache, enabled the distributed cache, the backplane, problem solved. It took one developer like 2 hours to do this. End of story. So this is really, really powerful. If you've been in production with this problem, this is a godsend. And now let's switch gear and talk about HybridCache, which is the new kid on the block by Microsoft. So you probably already heard about HybridCache. How many of you have heard about HybridCache by Microsoft? Cool. As Inigo Montoya will say, it probably doesn't mean what you think it means. And I'll show you why. So early 2024, Microsoft announced their own multi-level cache. And basically, let's see what they announced. It can be L1 or L1 plus L2. And for L1, it's iMemory cache. And for L2, it's iDistributed cache. They came up with a unified serialization mechanism and interface and abstraction to work with baud arrays for the distributed cache. And it has a global set of global options and some entry options with default entry options. And it transparently handles 1 or 2 levels and 1 or more nodes. Kind of. We'll get there in a second. So FusionCache design validated. I mean, I was happy about it because it was like, yay, 5 years earlier. So the features that it has are L1 or L1 plus L2, cache stampede protection, tagging, which is, again, really powerful, immutability, and in general, it targets .NET Standard 2.0. This is important. It came out with .NET 9, but it can target, you can use it from even the old ones or Unity or whatever. It just needs to reference the core packages v9, but not the framework itself. You see some asterisks there. There's a reason for that, and I'll get there in a second. The most important thing, in my opinion, is that they did not come up with their own HybridCache thing, their own library, etc. I mean, they did, but not just that. It's a shared abstraction and a default implementation of that abstraction. But again, first and foremost, it's a shared abstraction, meaning other people can implement that. It's like saying, for example, iDistributed cache for distributed caches, it's an abstraction. It's not a concrete implementation. And then they also did the implementation. In fact, the abstraction, which is the thing that came out with .NET 9, is in a public abstract class, HybridCache. That is abstract. And the implementation, which came out later, is an internal class, which you cannot use directly. You cannot like reference directly. Internal class, default HybridCache. And that is a separate package that you need to install. So again, it's not just a Microsoft-provided implementation, it's also, and first and foremost, a first-party abstraction, which is really cool, and we'll see why in a second. So think of the HybridCache abstract class as the iDistributed cache interface. Again, an abstraction for generic hybrid caches. How can you use it? Well, you install the package, which is, again, separate from .NET itself, and you basically do services.add HybridCache. That's it. You've probably already done this. And how to use it? Well, more or less like the one we saw before. We declare the dependency on HybridCache instead of FusionCache, as I showed before, and then we call getter create async, and basically that's it. Pretty easy. Small note here. I shared with the team when I saw this. People contacted me. Oh, did you see they're killing your project? Blah blah blah. Should you fight back? Blah blah. Long story short, I saw that as a good opportunity for the .NET community, if done well. And I have to say that they listened. I shared with them a lot of stuff. They're now known as my mega comments like this on GitHub. But basically, I share with them my experiences with FusionCache as a project and with caching in general. And the good thing, again, is that they listened. That was awesome. It's not to take for granted. It's a good thing to do, but it's not to take for granted. And I think the HybridCache effort is a great example of what it may look like when Microsoft and the open source community have a constructive dialogue together. And by the way, I would like to do a public shout out of Mark Gravel, the lead on the HybridCache effort, and the team, because again, they listen. We have a meaningful discussions about intricate details, and again, it's not to take for granted. Now, all is cool, but there are some limitations and issues. And I say this mid-2025 because this is for now. Now, if you're using or are planning to use HybridCache, meaning the Microsoft implementation, this is important because you may be surprised by some of these. So some are limitations and some are more like issues. Some are light and some are, I would say, more severe. And I think it's important to know them to avoid surprises maybe in production. Of course, it's their first version. It's a monumental task to make a multi-level cache. So, okay, takes some time. But again, you need to know them. First thing, no new. You cannot new up a HybridCache because the class is abstract, the abstraction. And as we saw, the implementation is internal. So you cannot do new and create 1, 2, 3, or anyway, even one direct instance. There's a builder, that's true. But the builder itself is also internal. So you cannot do that. So we need to rely only on the I, which may be cool, absolutely, but you need to know because it may have some limitations. For example, you cannot have control over during setup of what happens with L1 and L2, the memory level and the distributed level, meaning you will look into the DI container and whatever finds, it will use that. If there's an iMemory cache, that's your L1. You cannot use another one. You cannot configure that differently. And if it finds an L2, an iDistributed cache service, that's your L2. You cannot say, it's there for other reasons, I don't want to use it. On the other hand, if it's not there, you cannot have an L2. So if you only want to have an L2 on your HybridCache, but not register an iDistributed cache for something else that maybe work in the same, use the same behavior of automatically picking up stuff from the DI container, you cannot do that. So you need to be careful about that. Another thing is that it's only single instance. Now, the point of a cache is to be shared. That's, of course, that's a given. But oversharing can be problematic. For example, if any piece of code in your application is forced to use the same cache instance, you may have cache key collisions issues because multiple pieces of code can end up using the same cache key. You should be careful, you should use prefixes, suffixes, blah, 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 but it's not a given, so you need to be very, very careful. And also, again, no different configurations are possible. So you want L1 plus L2, it's just one, so everybody will be L1 plus L2. It's async only, which may not be a problem for some, but maybe for others, so it's important to point that out. There are no sync methods, so there's no get or create. There's only get or create async. There's only remove async. So if you have a piece of code that is sync only, you cannot call the method unless you do crappy stuff like .result or getAwait or getResult and stuff like that. Which, I mean, other thing, no get method. There are no methods that allows you to get data from the cache without providing a factory to create it. Now, this is more complicated. I I posted here this GitHub issue because it's a place where me and others in the community are discussing about how to possibly achieve a get-only method in the correct way. Long story short, as of today, to the best of our knowledge, it's impossible for two reasons. The first is that in an L1, I'll start with the second. In an L1 plus L2 setup, the behavior will not be correct, meaning it will not copy automatically the value from L2 to L1. There are some options to control what to do, some entry options for what to do with a method call in the HybridCache. And you can say, in theory, disable L1, disable L2, don't write to L1 or L2. I tried, but it's impossible for the first problem. It's non-deterministic. Now, we'll see that in the next slide, but not, mind you, I'd like to clarify, not the entire cache. Not HybridCache is non-deterministic. That would be wrong. What happens on a cache miss, so when you want to check something and maybe it's not in the cache, that is non-deterministic. You cannot control it, you have no control over that, and it's just pseudo-random, basically. And here it is. Basically, and this is pretty subtle. You may not find this when you try stuff locally, but when you're in production and this happens, you're like, what the hell is happening? Why? And this is why. When calling get or create a sync with a key in the factory, the expectation, which is A, common with any caching library, and two, documented in their own documentation, is that if the value is in the cache, so a cache hit, then it will be returned. If the value is not in the cache, then there's a cache miss, and so it will execute the factory. This is the baseline behavior that everybody expects and is documented. But currently, a factory may not run even when a value is not in the cache, and there's no way to know why. And there's no way to know it. Basically, again, the behavior is non-deterministic. So, for example, to simulate a get-only method, which is what me and other people in the community were trying to do, you can do this. You can declare a found variable, a bool, and set it to true. So you start from, OK, let's say it's in the cache. You call get or create a sync, and in the factory, what you do is you just return the default value, who cares, and you set the variable from the outer scope to false. You say cache miss, was not there. And then you pass some options to say, don't write to L1, L2. I just want to check. This is good in theory, but in practice, this is what you would expect to happen. So the cache is empty, you do that, all false, but in reality, this is what happens. And this is random, it can change every single time. This can be bad, so you should know about that. Because it's randomic. To the best of my knowledge, I look at the code, it's because of some optimization in the underlying cache stampede protection. It's a matter of sharing the same thread, the same task with multiple threads. And so you are not guaranteed that the factory will run on a cache miss. So that's the surprise. And then we have the other big one, which is distributed issues. HybridCache currently does not have something like the backplane in FusionCache that I showed you before. Meaning, if you are on more than one node or more than one instance, the cache will become incoherent. With the first update to the cache, the other nodes will stay back. So if you cache something for 10 minutes, and then on one node there's a change after 1 second, for 59 seconds, all the other nodes will keep using and returning the old value. Basically, in short, because of the limitations, in practice, in my opinion, currently it is not usable in production in a multi-node or multi-instance environment. And again, you should know about this before going down the road and using it in production, and then surprise, the thing is, I do F5 and I keep getting 3 different values. Why? Because you're going on different nodes, different L1s, different in-memory versions, and you now discover this issue. So, but as I said, I have a solution. As we said, HybridCache is also an abstraction, and other implementations, therefore, are possible. And FusionCache is a HybridCache from 5 years earlier. So, what can we do? Basically, FusionCache remains its own thing. I didn't change FusionCache to depend on HybridCache and be an implementation of. But I've been the first to say there is a value in being able to, maybe able to use a shared abstraction, even more so because it's first party provided by Microsoft. So FusionCache can also be used as an implementation of the new HybridCache, all thanks to a small adapter, and while keeping all the extra features that you saw And we saw just 2 or 3 of them, but plus all the others that we don't have to see right now. And how to do that? One line. We register FusionCache, and we say dot as HybridCache. That's it. We're done. Now, any piece of code that depends on HybridCache will just work without a single change. And the behavior remains the same, actually better because it's fully deterministic. So, as screenwriter guy will say, super easy, barely inconvenience. Who here knows who's screenwriter guy? A man of culture as well. Good. So, remember all those asterisks? Gone, basically. We have more features because we have failsafe, figure refresh, factory timeouts. Even when used as HybridCache, even as that abstraction, we can use them together, meaning not just the Microsoft implementation and FusionCache. They are separate packages. Of course, we can use them. But also FusionCache directly and via the adapter, the same instance. And because of that, we have stampede protection that is fully deterministic, first, so false, false, false forever. Unified, and not just unified, but also for sync and async, meaning the extreme example is I do HybridCache, the adapter in this case, but you don't know about that, dot getter create async, because it's only a sync we saw, and at the same time I do FusionCache, the underlying instance, dot getter set, the sync version. So 2 different abstractions, 2 different methods, one sync and one async. On the same cache key, only 1 database queries in total. This is really cool. We have total control over L1 and L2, because as we saw before, we can do dot with distributed cache, with backplane, blah, 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 and the registration for the adapter is the one by FusionCache, so we have total control. And then at the end, we just say, oh, by the way, this FusionCache instance exposed that also as an HybridCache implementation. We have the backplane, so multi-nodes support with instant updates, and therefore no distributed issues, bye-bye out of sync, caching coherence. And we even support multiple caches, because FusionCache supports multiple named caches, and it supports that even as a HybridCache implementation, which HybridCache, the implementation by Microsoft does not support, so I think it's pretty cool. And you can use that via keyed services. And remember the non-deterministic nature? This is the same code, again, with HybridCache, but with the FusionCache implementation. So all false all the time until the end of time. One final thing, and then I'm done. Small note here, personal note here. HybridCache, the abstraction, came out with .NET 9 in November 2024. And in January 2025, I released FusionCache v2, which contained the HybridCache adapter. And in March in 2025, Microsoft released the HybridCache default implementation. So FusionCache has been the world's first production-ready implementation of HybridCache at all, even before the one by Microsoft, which, you know, small thing, but from a Mr. Nobody from a little town in Italy, Canegrate, it's a nice touch. Anyway, let's wrap this up. So we saw how hybrid caches are awesome, at least I think. I hope I've convinced you. They combine the best of both worlds of memory caches and distributed caches, so L1 and L2, all in one unified and transparent API. And they have generally more features. Again, it depends on the library that you decide to use, but in general, that's the case because they are higher level. And to go hybrid, what should you do? What you can do is either, 1, use FusionCache directly. 2, use HybridCache with the Microsoft implementation, remembering the gotchas that you saw, or use HybridCache if you want or prefer or must use the Microsoft-provided abstraction as a dependency, as the dependency for your code, but with the FusionCache implementation, which is another road that you can go through. We have choices, so let's make the most out of them. And I hope you find this interesting, and I hope you will have something to test when you go out, when you go home. Thank you. Thank you. By the way, DMs are open, so if you want to contact me or do something, you can go on Twitter, on LinkedIn, whatever. Thank you.